Okay, so we're live streaming on Facebook as well.
We are live now. We're going to be live on YouTube. I'm going to turn the volume down so we don't have that reverb issue we had. Welcome to everyone joining us. Okay.
Anybody out there?
We're live streamed, so we'll see. We have people joining us so far. Nobody.
Bueller.
So let me see where we are on. Okay, we do have folks on our YouTube page. We have 2 people on our YouTube page.
Okay.
And we're just waiting for people to join us here.
What's the name of our YouTube page?
U46 Science and Planetarium. Just want to make sure we're live on that. We should be.
Okay, well, we're making sure we're live everywhere and we're loading up. I'm going to introduce myself. I'm Peggy Hernandez. I'm the planetarium teacher for U46. This is my 31st year being a teacher in U46, and I love teaching in my planetarium. And we also have Deb McMullen on board here, and she is the math, science, and planetarium coordinator. And we also have Sarah Rodriguez Horn, who is the amazing administrative assistant for the whole department. And we have Frankie Valencia, who is the secondary science coach, and Vince Fosco, who is the primary science coach K through 6. And I'm going to share my screen shortly, and I'm going to go through a PowerPoint that somebody in our group here is going to put a link to it in the chat so that anybody that wants a copy of it can have it. And this is the one I'm talking about. So this is Kickoff Event 3. This is our 3rd of 4. So on the top, you'll see that date to make sure that we're on the right one. Yep, today is February 2nd, Groundhog Day. And this is our STEM Expo kickoff because we are doing another STEM Expo on April 30th this year. It's going to be at Eastview Middle School for those that choose to present live. We are also doing a remote option, and I'm going to go through a few details on that in this program today. We want to give you an overview of the STEM Expo in general, and we really want to give you ideas and get you to start thinking. There's one more kickoff next week. That'll be the final one. And again, at that one next week, we're also going to put links in the chat for the documents that you might need, answer any questions that you have, give you information about the STEM Expo. And you'll get to hear from a paleontologist that has a specialty in dinosaur fossils that went to U46 schools. And her name is Carrie Levitt. So she'll be our featured presenter for next week. But what to expect for today? First of all, are there any questions? I'm not checking, so I'm going to rely on my team here to let me know if there's any questions.
So far, we're good.
Okay.
I'm monitoring Facebook and YouTube as well.
Okay, so the STEM Expo is on April 30th. It's a Saturday. You're going to be able to register via a Google form that we're going to have live starting next week. So the sign up isn't even available yet, but you will be able to sign up as an individual or as a group. You can do this with 1 or 2 other people. You have the option to present in person or online. And you can also, if you really don't even want to do it live on Zoom, you can actually make a recording of yourself going through your slide deck and submit the recording to us, and we will do it live on the STEM Expo day. You'll be provided feedback on your project. It's not a contest. This is not a typical science fair that your parents or your grandparents might remember, where you have to find some kind of amazing experiment. It's an investigation that interests you, and it can focus on science, technology, engineering, or math. You could be really interested in statistics and data, and that could kind of be a focus of a STEM Expo project. So since we don't have judges, we don't like to call them judges, but we don't know what else to call them. So peer review panel members, it's kind of long, but these are just adults that are going to listen to presentations and then give students feedback and ask questions about their presentation. We could use volunteers. We need help with check-in, monitoring the space. We're going to run some virtual rooms, so we'll need people that can do that. And any community partners that happen to be on here, we'd love to hear about any phenomenon or any problems in the community that you'd like to share with us that we can share with our potential participants. Maybe sign up to support a student who wants to do a really cool project, help them through the science. You can always email Debbie McMullen at u46.org if you are able to help in that way. So what then is a STEM Expo project if it's not a science fair? Well, it's phenomenon based. It's something that you notice. In a very simple sense, a phenomenon is simply an observable event. But it's often an amazing observable event. It's an amazing thing that happens that maybe you thought wasn't going to happen, but then it did happen, or something you thought was going to look like one way and then it turns out happening another way, or just something that you find really, really interesting. So I have a phenomenon I want you to watch. It's only a minute long. It's a video. A phenomenon can be in the form of a video. Oh, hold on. There's no sound. You don't need sound. And what they did at the beginning was, these are the Jolkowski boys, by the way, and they put Mentos in Coke. And this is what happens. This is in slow motion. It's an amazing phenomenon. I've seen it before. This has been around for a long time. There's definitely some chemistry involved. It's interesting to learn why this happens when two substances come in contact with each other, but it only lasts for a few moments. And I want you to watch what the boys do right away. For me, this is the phenomenon. Look, they found Mentos left over, those little white things. Within seconds, these boys started dropping the Mentos back in. Yeah, let's make it explode some more. Shove it in there, put the Mentos in there. Let's see what happens. But nothing else really happens. It's not exploding again. Why did it stop exploding? Why isn't it working anymore? Why is there just one big explosion and then at the end there was leftover Mentos, but then it didn't do anything? That is a phenomenon. That's an amazing event that you could do an investigation on. That could be your STEM Expo project, either the Mentos or the idea that the Mentos explodes, the soda just shoots out, but then when there's Mentos left over and you drop it in, it doesn't do anything. So what's up with that? Why does that happen? That is an example of a phenomenon that can be used to be your base for your project. So as you're thinking through your project, sometimes it's hard to get started. Sometimes you have a good idea and you don't even know what to do with it. Sometimes you have an idea and you think there's no way, I don't even know how to investigate that. Well, there's ways that you can think through the project. And the first step that you're always going to do is figure out some questions. If I was going to do something with the Mentos, the first thing I would do was write a humongous list of questions. Why did it do that? How far up did the soda shoot? Why was there Mentos left over? Should there be Mentos left over when I put it back in? Why didn't they shoot up again? I would go through a whole list of questions, and then you can often categorize your questions. You can put them in different groups. You can narrow it down to one really good question, and that can be the focus for your project. The other one, there's two pieces that are going to help you, and you can get links to both of these today in the comments. First of all, we have a link to a document that is actually I already have it loaded. It will help you with your board. Once you sign up, you're going to get a board sent to you. And this document, it's just a Google Doc. This document will help you because it has a list of questions that you should answer on your board somehow. This is not an old-fashioned scientific method science fair. The scientific method really is part of the science and engineering practices that we use today as scientists. I mean, you could do an experiment, but you don't have to do an experiment. You can have a project. And maybe you can have a project that focuses on some other part of science and engineering. And the links here will help you know what those other practices are that you might make a connection to and say, hey, I could do my whole project on that. So this document will help give you ideas. The other document, the virtual pre-recorded presentation template, it's a slide deck. Now, when I click on this, I want you to see what happens. It says, oh no, Google Slides, copy document. That's fine. That's what you want to do. We want you to copy this whole slide deck onto your own computer. It will work better on a computer than on a phone, but here's what it looks like. It's a grand total of 9 slides. Slide 1 is where you just put your title for your slide. You can call it whatever you want, make a name for your project. And when I click on it, this box comes up because I can write in here and I would put my name. And it doesn't matter what your name is, you would just put your name here. And then in this box, I'm sorry, I said it wrong. This is where you would put your title, call it whatever you want. And here's where you would put your first name, just your first name, not your last name, not your school, just your name. And everything else that's in white, you can't change it. Those are kind of like the directions. Slide 2 asks you to tell us what is your phenomenon or the claim that you're going to make or the question that you came up with, at least one of those things. And you just have a text box there and you can write in it. The next slide is a checkbox. Put an X next to any of the science and engineering practices that you used. What are the science and engineering practices? Well, down here in the notes, you can click on a link that lists them for you. And maybe you only did one of these things. Maybe you want to use math and computational thinking because you love math. So you're just going to put an X on that one right there. You're going to make a text box. You click the text box, put it right there, and you say, that's what I'm going to do. And I also am going to make a really cool data table. So you're going to do another X right here. And then on the next slide, it's going to ask you to describe those practices you used. What did you do in your project that made you think that that was one of the practices you were using? You just describe it. On the next slide, you're going to tell us what evidence you have. What did you gather? What did you learn about the Mentos? What did you do to learn about the Mentos? What did you figure out about the Mentos? What kind of evidence do you have for answering those questions? It might be a data table. It might be numbers. It might be a graph. It might be a chart. It might be information you got from an expert. And every single science phenomenon has a connection to one of these cross-cutting concepts. What are the cross-cutting concepts? Well, they're these right here. And if you want to know more, down here in the box in the bottom for notes, there's some links that will describe them for you. And if I do a math project, I might say, oh, my math project totally had patterns in it. I'm going to open my text box here. I'm going to put a big old X right there next to patterns because my project was about patterns. Maybe it's about energy and matter also. I could put an X there too. And this is a graphic that might help you think about the connections of your topic that your Expo project is about and to connect it to the cross-cutting concepts. This is just a graphic for you to look at. And then you're going to tell me about why you made that connection. Why did you pick patterns and energy? what did that have to do with your project? And you just describe it. And then the last slide is you telling us about what you would like to do next year, and what did you like about the one this year? And if you had to do it over, what might you do again? And again, you'll just make a text box, and that's where you're going to put your answer. If you save this whole thing, this is what you'll use to do your presentation if you do it remote. So this is for the remote presentation, or you can record yourself reading through each slide and then give us that recording, and that will be your submission for your STEM Expo project. Do we have any questions?
The only question we have is this for the in-person version?
That slide deck
Yes.
is for the remote, and that slide deck tells you, hold on, asks you the same questions for the in-person one. The presentation board document, these are the same questions 1 through 7 here. They're the same questions that we have on the slide deck. If you want to do the slide deck, even though you're going in person, if you want to answer the questions on the slide deck and then print them and put them on your board, go for it. It's the same questions. We want you to be comfortable to do it whatever way works for you, and that would be fine. You could use the slide deck, write your answers in, and print them and use them to answer these questions and put it on your board, and that could be your project. That's a great question. And you, Ms. McMullen and team, do we agree with that? Is that correct? I want to make sure I'm not over speaking.
No, we absolutely agree with that.
Okay.
Yeah, good answer.
Some people would be more comfortable filling out the slide deck because it's kind of pre-made with questions. And if you want to just attach that to your board and then do it in person, I don't see anything wrong with that. Okay, so let me open this back up big because I want to get to the stars. We're going to do a little star show. So the first part was questioning with a really good question. You do your investigation. What do you think will happen, or what is true? This is where you might create a model to explain what you're trying to figure out, or a model that you're going to experiment with. Like, I'm going to try it this way, and then I'm going to try it this way. And I wanted to see which way would do it better. There's a video in this slide about creating a scientific explanation. How can you test it? There's tons of ways to test a phenomenon or a problem. And these are all great examples. Make or record an observation, create some kind of a physical model, use reliable resources and research, find an expert in the field and talk to them. That's totally valid. You can interview people, you can conduct some kind of experiment. All of those are valid parts of the process. And if you do them, we want to hear about them in the STEM Expo. So these are for next time. And so that's basically the overview. The link to sign up to register is going to come out next week. It's Saturday, April 30th. If you do a live and in-person one, you're going to have a time slot. And we're thinking that's to keep numbers down at any one time at Eastview. We don't want too many people in the gym at one time. And you'll have a 2-hour window where you will present. Probably morning, like a 9 to 11, and then maybe something like a noon to 2 presentation time. Any questions so far?
Not so far. I think you've been clear.
All right. So any good STEM Expo project is going to start with the phenomenon, an amazing sight, an amazing thing. Like, here's a phenomenon with astronomy. The sun is an average size star with an average brightness. Now, I'm telling you this because I know astronomy. I guess you could call me an expert in this, but I do know that scientists have figured out that the sun, compared to other stars, is average size and average brightness. but yet it burns my skin in the summer when I go outside for more than a half an hour. And it's so bright, I can't even look at it, and I have to put sunglasses on sometimes. How can that be? The rest of the stars that I look at night look way, way smaller. That's a phenomenon. That's something that's something you could investigate. What's up with that? Why does the sun hurt my eyes if it's not very bright? So the coming up with the questions part would be next. Well, why does that happen? How far is the sun? How really big is the sun? How big are other stars? How far are other stars? And when we start thinking about our investigation, we narrow it down to one focused question. And remember, the best questions are going to address the phenomenon. They're not statements. They're not telling of facts. They're questions that don't have one-word answers. They can be observational. They can be looking for an explanation. Well, how does it work? Or what happens if? Or can I predict? So here's my question. How is the sun so bright if it's not a very big or bright star? And I did some connections and I thought, this is looking for an explanation and maybe talking about the whole solar system in general. So that's the question. How is the sun so bright if it's not a very big or a very bright star? Well, I did some investigating and I looked back at what I know about science. And I can tell you that the moon is less than 1 million miles away. It's actually way less. It's only like 240,000 miles. That's it. Less than 1 million. The sun, we know, is just under 100 million miles away. Now that's pretty far. So the moon is less than 1 million miles. The sun, about 100 million miles. Well, the next closest star to us is 4 light years away. But that can be confusing. What do you mean light year? What's a light year? Well, a light year is a distance that's way bigger than miles. It's kind of like if I told you, and I'll tell you, I calculated it on Google. I live 506,000 inches from the planetarium. 506,000 inches, 500,000 inches away, plus some. Does that tell you anything about where I live? 500,000 inches, that's so many. I'll bet it would help you if I said I live about 8 miles from the planetarium. Yep. When we start talking about stars, using miles is a ridiculously small unit. So we use a bigger one and it's called a light year. And that's because light travels at 186,000 miles per second. Man, that's fast. You turn on a light switch and it travels at 186,000 miles every second. And if we could let that light go for an entire year, nothing got in the way. It just kept on going 186,000 miles every second. In 1 year, it would go about 5.8 trillion miles, hundreds, thousands, millions, billions, trillions. 1 light year, 5.8 trillion miles, almost 6 trillion. So that closest star to us, Alpha Centauri, that's 4 light years away, is 5.8 trillion times 4, 25 trillion miles away. That's why it looks so small in the sky. Stars at night are so much farther than the sun. Here's where the moon is. Here's where the sun is. Look at all those extra zeros. The stars at night aren't very bright because they're incredibly, incredibly far away. And it can be tricky. Here I have 2 tea candles sitting in my living room. It's just 2 little candles. And they're sitting next to each other, right? Well, I was on my knees taking this picture, even with a chair. When I stood up and took a picture, it looked like that. Now wait, let me go back. Hey, they look the same, don't they? But look at them carefully now. Look at the brightness of this candle compared to the brightness of this candle. Can you tell that the one that I have on the coffee table is actually a much brighter light? It is. I purposely put them different distances so that when I looked at them side by side, they looked the same. Distance makes a difference with light. And here's another example of the same thing. Only these two candles are identical in lumens. They're both night lights. But look carefully at the one that's closer. Doesn't it look brighter? It does, because it is. Closer lights look brighter than farther lights. So if the stars at night are farther, doesn't that make them much dimmer than the sun? Yes, that's exactly what happens. And to me, it's amazing how big the sun is. Look at that. It's gigantic. And it's not the biggest of all the stars. The stars you see in the nighttime sky, most of them are bigger than the sun. Oh, there's a lot that are the same size. It's an average star. But the ones that we can see from here are usually bigger than the sun. And if that's the sun, and this is Jupiter right here, right there is little old planet Earth. That's the Earth right there with the little moon next to it. So there's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and that little pile of crumbs. Those are 4 of the dwarf planets. One of them is named Pluto. Another one is named Eris. It's almost exactly the same size. Then there's Makemake and Haumea. That's the 4 that are sitting there. So let's go look at some of those stars in the nighttime sky. I'm going to switch over to Stellarium, which has a web version of this very same observing program. It's free, open source, it's safe, and I love playing around with Stellarium. This was 9 o'clock this morning, only it didn't look like this outside because it was downpouring snow everywhere. So we couldn't actually see the sun, but we knew it was there because it was making the clouds, the whole sky was really, really bright. And it rose in the morning and it moved across the sky just like it always does. But I want to show you something really neat at around noon or so. Here we are. We're at 11:45 right now, almost noon. The cool thing about Stellarium is I can pretend like we can turn the sun off. No light. And if I turn the sun off, I'm going to do it right now. During the day today, when the sun was up, Mars was up, Venus was up, Mercury was there, the sun is right here, right next to the sun, right there. And you can barely zoom in on it actually. Nope, look at that. Let's see if we can click on Saturn. I mean, they're not actually next to each other. No, they're not actually right next to each other. Saturn's actually way behind the sun, but that is Saturn. And then Jupiter. All 5 planets that we can see naked eye, and that just means with no telescope, they were all up today with the sun. Now, as time goes on and the world spins, everything moves towards the west. And if you watch this happen, can you tell that Mars and Venus and Mercury, they're going to be gone before the sun even goes down? We will not see them in the evening sky. We will not see Saturn in the evening sky. It is so close to the sun. I got to go back to daytime. Saturn is so close to the sun, it would blind us if we tried to really look at it. But we did have a new moon 2 days ago. The moon was right underneath the sun 2 days ago at this time. And every day it moves a little bit to the left in its orbit. So tonight the moon is going to be up about in the same spot as Jupiter. Down, down it goes. So we're at about 4:30. I've been noticing it's not dark at 5:30. The days are definitely getting longer. But as the sun approaches the horizon, the sky starts to get that cool evening sunset look to it. And we're going to let it go down. And we should be able to see Jupiter as it gets dark. Or if you can, turn all the lights off in the room that you're sitting in. This looks way better if it's dark. Down, down, down goes the sun. Ooh, the sky is looking darker. I'm going to turn to the left a little. Oh yeah, some stars are getting visible. Not a lot of stars over here by the moon and Jupiter. And just so you know, I have the moon expanded bigger than it really looks in the sky, just so it's easier for us to see. So the moon is a tiny little waxing crescent tonight. And it's clearly visible outside right now, except for it was cloudy at sunset. And the clouds are blocking it out. The moon's going to go down about an hour after sunset. But then that means we've got our whole evening sky right here. You see a lot of satellites going by. Super normal, super common, happens every night. So here we are at 7 o'clock, about the time we're going to be done with our presentation here. I'm going to stop the Earth from spinning. I'm just going to completely stop. I want you to take a look and see if there's anything you recognize. I'm going to back up a little so you can see more of the sky at once. They label all the planets and when they're up in our direction, and Uranus is up right now, but that's not one of the planets that are visible unless you have a telescope. Does anybody see a little bit of Orion the Hunter, the 3 in a row that make up his belt? I'm going to draw in the lines. There's not a lot of bright constellations in the West in January and February. And on Stellarium, like every other star chart, the smaller the dot, the dimmer it is in the sky. And these 4 are, they're okay. They're not super bright, but that's the great square of Pegasus. And this right here is part of something called Pisces, the fish. I can put in the drawings of the creatures, the Greek mythological characters, and then I can add the names of them as well. Cetus, the sea monster, is right after, next to Pisces. Lepus, the hare, is underneath Orion. You know what? Let's turn our bodies, spin to the left a little, which means we're going to look more in the south sky. And if I'm looking in the southeastern sky, that's where all the bright stars are in the winter. And if you go out any night this winter, from now until springtime, Orion stands out. You just can't miss it. I've seen it from the Walmart parking lot. These 3 stars are so bright. And there's this big rectangle, and the 3 stars in a row are his belt. Now, if you follow his 3 stars up, they run into this orange star that's the eye of Taurus the bull. It's connected to what looks like a letter V. And that's the face of the bull. That's the angry red eye of the bull. Zoom in just on those 2 a little bit. That's the eye of the bull. That's his nose, and that's his other eye. And if you have a really good imagination, you can follow up to the tip of one horn. He has really freakishly long horns. And then go here, and there's the other horn. And here's what it looks like if I connect the dots. Oh, Gemini the twins too, right there. 2 matching twins. That's 2 brothers, and they're holding hands, and there's their arms. If I draw in the pictures, sometimes that helps people imagine the constellation. And almost straight up. So I'm going to have to drag the screen a little bit more, almost straight up in the sky tonight. If you keep going past Orion and the letter V, you'll bump into this beautiful little cluster of stars called the Pleiades. It's called the Pleiades. It's not a dipper, although some people think it looks like the shape of a dipper. It's just a beautiful little cluster that you can cover with one finger. It's called the Pleiades. Orion's belt going the other way, if you follow it, like you have a ruler attached to it, it takes you to Sirius, the dog star, the brightest star in the sky for human eyes to see. And
Yes.
it's a really hot
I'm so
star.
sorry.
Yes.
A question came in from YouTube that might be timely. The question is, how did the constellations get their names? So they're referring to back to the rabbit constellation. They're, they can see it when you put the drawing in, but they kind of are like, well, how did people decide that looked like a rabbit? Do you know?
Oh, that's a really good question. And That's because people have amazing imaginations, and every culture on Earth made up drawings in the sky. And some, I guess you could say some are more famous or some are more well-known than others. Many of the constellations that I have up here right now are the Greek mythological characters. And there are, on Stellarium, if you have the full Stellarium, you can program in different cultures and you actually get different pictures. In Japan, Orion the Hunter, what we call Orion the Hunter, is actually a drum. They connect this line here and it's cinched in the center, or some people think it looks like an hourglass or a bow tie on its side. And Lepus, the hare, it's a rabbit right there. Yeah, if I look at just the outline of it without the picture of the rabbit, I don't think it looks like a rabbit at all, except for maybe those two ears. So it's humans that made those up. How did they get famous? It depends on who was telling the stories and how popular they were, I guess. And the Greek mythological characters really
interesting. So like if you were doing this show, just for myself, if you're doing this show, we could name them differently depending on the culture?
Yes.
You think? Wow, that's cool.
Definitely. And I think there's like a Swahili one that the 3 stars in the belt are actually the heads of 3 giraffes. I don't know the full story behind it. I have to look it up. There are so many stories in the sky. Actually, that's a great book to look for when you go to the library. Stories in the sky or mythology in the sky. And you can check out books that show you all the drawings that people have made up over time of these stars, especially in the winter sky facing south. There's so many bright stars. The little dog right here. That's it. It's just one bright star and another one right next to it that's not very bright. That's the whole dog. Looks like he's riding on the unicorn's back. Monoceros, they call it, not the unicorn. And there's a ton of amazing stuff in the sky. And if we keep going to the left, go a little bit more towards the east. Now we're facing east, northeast. One that's just coming up right here. It looks like a backwards question mark. And that's actually the furry mane of Leo the lion. So Leo the lion, Cancer, Gemini, Taurus, Pisces, Aries, Pisces are kind of all in a line here. And if we're facing south, it's a line that rises and then sets. It follows the same path that the sun crosses during the day. Once we're towards that east, though, and we're looking at Leo just coming up, east, northeast, I wonder if anybody's noticing the Big Dipper. It's right here. The Big Dipper. Oh, tonight when it gets dark out, the handle is sticking straight down into the earth. It might even be blocked by trees or houses or fences where you live. And the Big Dipper is just part of the constellation called the Big Bear. And if you have a good imagination, this is the body of the bear. And that triangle, that's her pointy snout. And here's her front legs, and she has 2 front paws. And here's her back legs, and there's her back paws. You have to have a good imagination, but it kind of does look like a big bear in the sky. You can always use the big 2 stars in the Big Dipper to point to the North Star and Little Dipper right there. So Big and Little Dipper are definitely up tonight. The Big Dipper's very low in the northeastern sky. So if we're facing due north, exactly north, with the North Star right there in front of us, about 40 degrees up, you could find the Big Dipper standing up on its handle, use the pointers to get to the Little Dipper. And if you keep going, you'll bump into Cassiopeia the Queen sitting in her chair. We look straight up in the sky, a little bit higher. We got Perseus up there. Perseus ends up marrying Cassiopeia's daughter. And her name is Andromeda, and she's riding away on the horse with wings. And, oh, there she is. She's hanging around upside down right there. That's Andromeda right there. Near Pisces the fish and riding away on Andromeda or Pegasus, the horse with wings. And we're back in the western sky. And if we were to let the night go on, we would see stars setting in the west, new ones rising in the east. And that's how it happens all night long. I'm going to spin to the left. So we're going to be facing south. So we can watch that movement. Down, down, down goes Orion. It's after midnight already. All those bright stars went from the east to the west. Oh yeah, new stars are coming up, taking their place. There's always stars out there, daytime or nighttime. There's always stars in the sky. Ooh, once Venus comes up, I know we're getting close to the sun. Mars, Venus, and Mercury, and then the glare of the sun overpowers them because that sun is so much closer than the stars at night that it overpowers us seeing any of the nighttime stars. Nighttime stars are there, we just can't see them. There they are. If I turn off the sunlight like a light switch, you can see them, and if I turn it off, then all we see is the sun. And notice the moon is a little bit bigger because we are now on February 3rd. On February 4th, the moon will be there. And on February 5th, it'll be there. And on February 6th, it'll be there. And what you're going to notice all week this week is that the moon's going to get bigger and bigger. And here we are, back where we started. Does anybody have any questions?
There's a question
Stellarium.
coming in from YouTube, and it's more about you. It says, do you, and I'm assuming they mean you, do you have a favorite constellation or constellation story?
I would have to say Orion's probably my favorite constellation. It's so bright and it's so delightful when I'm with someone and they spot it for the first time on their own. And it's so noticeable, it makes it easy. So I always look forward to wintertime. I like wintertime because it gets dark earlier. I know, that's weird, but it gets dark earlier and I can go out and watch the sky. I don't have to wait until 10 o'clock at night. So I love Orion. And as far as the stories, I don't think I have a favorite one. I think one of my favorite things to do, instead of the traditional Greek mythological tales that here in Western culture that we listen to, I like to look up and listen to some from Asia or some from Australia, or maybe star stories of the Inuits up in Alaska. I just like to hear different stories.
Yeah, that's very cool. I think I've watched your star show as your friend for many years now. And to hear the different stories, I just didn't think about that before. So that's really cool. I want to learn more about that. There's another question from YouTube, and it's, do you need a lot of fancy technology to do star watching?
No, that is another excellent question. No, you're born with it. Just your eyes are the very best first observers of the night sky. And your next step, if you wanted a tool, would be a pair of binoculars. And when you're outside and you get to know a few constellations, if you keep noticing a fuzzy spot or an interesting looking star or one that looks colorful, you would start by just trying to spot those things with the binoculars that you hold up to your eyes. And then if you continue to be interested in the night sky, your next step would be a telescope. Maybe you're interested in photography through your telescope. And there's kits where you can mount your cell phone onto your telescope. There's kits where you can mount fancier cameras onto your telescope. And you don't have to do it all at once. As you get interested in the hobby, you can gain more and more of the technological tools, in addition to the know-how, because you'll be outside practicing. As a matter of fact, I would not recommend starting with a telescope. Most people that have a telescope that contact me have no idea how to use it. And until you're ready to learn how to use it, you're probably better off joining a club and going to their open nights, which the Northwest Suburban Astronomers have regular open nights. Fox Valley Astronomers towards the south, they also have open public nights where you get directions and they go to a certain forest preserve or somewhere dark, and you can go early before it's completely dark and meet the people, and they'll let you look through their telescope and they'll show you how to work it. And that's the best way to start learning about using a telescope and figuring out what kind you want.
I think I know what this question is. It's saying, can you tell us about the 5 planets aligning again? I think they're talking about the last time we were, when those 5 planets are, I think this is what, in June?
Yep, that could be. And it's sort of related. I mean, right now, I can show you at around noon tomorrow again. We've got all 5 visible in the daytime. We've got Jupiter on this side of the sun, but we've got Saturn over here, and then Mercury, Mars, and I missed Venus. Where is it? And Venus. And in the next month, Venus is slowly going to end up on the other side of the sun. So all 5 of these planets are going to be on the right side of the sun from our view from planet Earth. And what that means is at sunrise, so let's go back to that. Oh, it would help if I did this. So here we are at sunrise, right before sunrise, only instead of February, if I go to June, right before sunrise, still a little bit dark out. I'm going to back up a little bit. As the sun's coming up in June, we're going to be able to see, go back a little bit, all 5 of the planets before the sun comes up. There's Venus, there's Mars, there's Jupiter, there's Saturn. I'm missing Mercury. Oh, we got to go back a little earlier. That's why. Other way. A little later. Mercury, just barely visible as the sun's coming up on this date. I think I should go later. There it is. That helps. So if you go to June 20th, that's what you need to do. Head to June 20th. It's a little too bright out there. 4:38 in the morning, around June 20th, Mercury, Venus, Mars, Jupiter. Oh, the moon's going to add in there too. And then there's Saturn. All 5 planets and the moon in a row. And I'm going to go out on a limb here and tell you, if you're in bed sleeping, you won't even know what happened. Your energy is not going to align. You're not going to feel it. It's not going to make you happy. It's not going to make you sad. It's not going to change your water inside of you. It's not going to change your energy. It's just a really neat event to watch if you can get up at 4:30 in the morning on June 20th. The 19th and the 21st will be good too.
It sounds almost like we should make an event calendar for our planetarium Facebook page maybe, and let people know it's going to happen, so they could wake up and
Yeah. Yep. I have a feeling it's going to be on the media.
Yeah. Right. As one of the events.
Make things up about planet alignments. Yeah.
Right.
It gets very popular to post misinformation, but as long as you know what the misinformation is, as long as you know it's not going to do anything, it doesn't cause any imbalance in the solar system. It's perfectly normal. They're not actually all lined up from above. If you could look at the whole solar system, they're just lined up from our point of view. And it happens every once in a while.
So one other thing that I think people are very interested in is how did you become so interested in planetary science and in the work you do? How did you become so interested?
I've always been interested in looking at the sky. I think the first time I looked through a telescope and saw Saturn like floating out in space, that's how I perceived it as. I thought it was amazing. And then as an adult driving up in Wisconsin, I saw a fireball, which is a really large meteor, and it had color to it. It had like greenish tint to it. And I was hooked, and I joined a local astronomy club, and I was a teacher at the time, and I got really interested in teaching it with my 8th graders. And then we did a star party, and then I joined the club, and then I went, and I just kept learning more and more about astronomy. And then ended up with a teaching position in the planetarium because I ended up knowing so much about astronomy, not only because I went to college and I took a lot of science classes when I was preparing to become a teacher, I had a personal interest in it. So I would spend some of my time outside of work for fun, learning about telescopes and looking at the sky.
So a follow-up question that came from YouTube is so this is a 3-part question. So first, YouTube, what's a star party? But then I'm wondering if you could also answer, why should students do the STEM Expo? And then thirdly, why should they be online tomorrow? Or I'm sorry, on February 9th for Miss Carrie Levitt's program?
Okay, so, okay, maybe I'm gonna put an idea sheet up. I have a slide of ideas. Well, first we'll go to this. I'll answer the last one first. Next week on February 9th, we're going to have on the Zoom for a half hour to do a little show for us. Carrie Levitt Bassian, who is a paleontologist at the University, the Natural History Museum in Utah, and her specialty is dinosaurs. And you can read it on the little sheet here if you have it, that her expertise is in ceratopsian limb bone histology. In other words, she knows a lot about the bones of dinosaurs, and she shows us some really cool stuff. And she went to Bartlett Elementary, no, maybe Centennial. She went to a Bartlett Elementary School, Eastview, and Bartlett High School, and became a paleontologist, and now lives out there. And she's great fun, and she's going to help us learn a little bit about dinosaurs. And we're doing all this because we want to show you that there are so many interesting fields in science that you can do almost anything for your STEM Expo project. There's any science, technology, math, or engineering phenomenon that interests you is worthy of a STEM Expo project. It's fun to learn. It's fun to get feedback from adults in the community. It's fun to show off to adults what you know and what you did. So that's why we do a STEM Expo. And I was kind of brainstorming when I was thinking about science phenomenon, specifically astronomy stuff. You don't have to do your project on astronomy, but since I do astronomy, I have a whole bunch of ideas on that. And this slide right here kind of shows you those ideas. So I think I answered 2 of those 3 questions, but what was the first one again?
The first one was what a star party is.
Oh, star party, woo, party. Well, when I said I had star parties, when I was teaching 8th grade at Eastview, my students had to do a star journal. I asked them to go outside and make some sketches and make some comments about what they found. And I started meeting them out on the football field. And then we switched it to the Bartlett Nature Center. And so anybody that had a telescope could bring it, and like a bunch of people get together and they set up their telescopes right before dark. And then you just look at stuff in the sky. That's a star party.
It sounds amazing.
They're fun.
Really fun, yeah. And I think you did a really good job of answering all those questions that people had. And it doesn't appear that people have questions about the event, so that's good. I think we're getting information out to people. And so I guess with that, thank you, Ms. Hernandez, for sharing your vast knowledge of the universe with us.
Of course.
I know I always learn a lot. Ms. Rodriguez-Horn, do you have anything that you want to add? I mean, I just know that we're going to be opening up registration for folks. We'll be doing that, next week, right? And we'll do that. Okay.
When you register, you'll get the slide deck that has the questions, and you'll get the information on how to do your board. And your board, correct me if I'm wrong, will get delivered to your school, because you're going to enter your school and your name.
Yes, that is all correct. We'll have 2 registration forms, one for individual register people. So I'm doing my project by myself, and one for a group. And you can have up to 3 people in your group if you want to, and they don't have to be at the same school. They don't have to be at the same grade. We've had a lot of brothers and sisters do it, which is great because that's always fun to see. So all those things will be options.
Which reminds me, you also can sign up to do this if you are in U46 boundaries and you're homeschooled, or you go to a private school of any kind. You are welcome to join in on the STEM Expo. We would love to see you and your project.
Yes, absolutely. Everyone is invited. We want everyone there. The whole idea of this again is to just get you guys thinking and sharing with us. We get so excited as a science department to see your project. And so we're also here for you to support you if you need ideas or you want to bounce ideas off of us. We're very here, we're very here for you. We're here for you. Yeah.
Yep. We don't want to keep it like, it's not a science fair where you would Google science fair projects or buy a book that says 1,000,001 science fair projects that 1,000,001 people have already done. You don't want to do a science fair project that everybody knows the answer to and just follow the steps like it's a cookbook recipe. We would rather you investigate something that you're interested in and learn a little bit more about it. And I'm not talking about solve all the problems of the world, but just your little tiny section of the world. Find something that you're interested in and show us how you learned about it and tell us what you learned about it. And you're doing science, you're being a scientist. That's
like the Mentos example that you showed today. Why does that happen? I haven't had a chance yet to post I try to post a phenomenon on my walk to work. Today, my phenomenon has to do with sound. So sound travels in waves. And one of the things that I have noticed over time is that when there's snow, when we get a good amount of snow, it's quieter. And I was kind of wondering about that. So, yeah. So, I mean, that's something you guys could do your project on.
And even if you're not interested as much in the hard sciences, the Mentos example is great. I know about the chemical reaction. I wouldn't do that one because I know what happens with Mentos and Coke. But I was very interested in the human part. Like, why did the Julkowski boys immediately want to put more in? Do we just like explosions? Is that it? Like, and what would make you think that adding the Mentos that shot out would make it happen again? But then it didn't happen again. So why didn't it happen again? So what's the story with those Mentos? I think there's more to it. And what's the story with everybody does that? Everybody, after their Mentos is done, when I did it with 8th graders, they would try to stick the Mentos back in and make it happen again. And it never did.
Yeah.
Is it trying to make it happen again? I don't know. Does everybody want
that? We keep telling people that our office theme is what's up with that. That's our theme. We want to know what's up with that. Whatever it is, we want to know why it's happening and why you're interested in it. And we've had students projects who the student might say, oh, my project was a failure. And what's out of that is they're passionate about what they did and their understanding of why it didn't work and how they would do it the next time. And that's how science works. So we're just looking for whatever you're interested in, some local thing, some simplistic thing that you might think is simplistic, but we just get so excited when we see students what's going on around them.
Maybe you want to figure out a way to build a rubber band car with paper clips and straws and index cards. And maybe you figure out a way to do it. Find some ideas on the internet, you practice, you do it a couple times, you find and get one that works. That could be your STEM Expo project.
Yeah.
What if it falls apart? What if it doesn't work? What if you can't figure out a way to get the thing to roll? That's still your
science. Not working is science. Yeah.
Exactly. If you can tell us why it didn't work and what you think might make it work, and you add that to part of your project, that is a satisfactory project, even if it doesn't work as I thought it would.
Yeah. I was hanging out with some 5th graders earlier in the week, and we were talking about why snowflakes look different. They were looking at photography of snowflakes, and I can't remember now the name of the gentleman who was the first to photograph them, and I should, because they were reading it on him, and they just showed all the different pictures, and their question was, well, why do snowflakes have different, you make them right, with paper and you make the different shapes, but like in real life?
Yeah, and I know it has to do with crystals and math and patterns.
And maybe temperature
in the slide deck. Temperature.
Yeah, the actual 5 characteristics of water. Yeah.
Yes, characteristics of water. There's all sorts of good science in there, and it doesn't have to be an experiment. It can be investigating something that is amazing to you that makes your brain say, well, what is up with that?
Yeah.
What's
What's
so
up
good
with
with
that?
snowflakes? What's up with that?
Yeah. Yeah, absolutely. Well, another wonderful evening. I appreciate you so much, Mrs. Hernandez, and also the rest of our science staff. Amazing people. We're so excited to have you guys do these projects. We hope you join us on the 9th for Miss Levitt. And I forgot her married name, Levitt
Bassian.
Bassian.
Levitt Bassian.
That's going to be a really fun evening. So come with lots of questions and tell all your friends. And thank you so much for being with us tonight. And thanks for sharing, my staff. Thanks for sharing everything you guys know. So, bye.
Bye, everyone.